Hi everyone, and welcome in this part of the workshop where we will see how the single reaction chamber can give some benefits for the digestion of one of the most stable and difficult samples to fully digest. And I'm talking about the advanced materials. What does it mean, advanced materials? Basically, with these words, I'm including a lot of different types of matrices, but all of these matrices are usually specifically designed to have to bring some new improved technical properties. And these materials are materials that normally have special chemical compositions that are used to be used instead of traditional materials in order to have final products with higher performances. These type of materials are mainly used in all kinds of industries, from aerospace to building construction, healthcare, and also transport. Especially nowadays, these type of materials are very used for the production of electric vehicles in the lithium-ion batteries part of this type of the vehicles, of course. So even these materials are subject to the elemental analysis. Why? Because the purity of these materials can have an impact on several aspects, like the performance, like the manufacturing costs, like the environment for the recycling part of these materials. So the elemental analysis is anyway an aspect that is important for this type of samples. And the elemental analysis, elemental analysis sequence is exactly the same as for any other kind of samples. So normally the material is grinded into a fine powder, then this powder is digested, so it is dissolved into acids solutions that then is injected into an ICP system for the analysis to collect the final data. Of course, all these steps are connected and all of them influence the final data. But now, today, we focus our attention to only one aspect, that is the sample preparation and the digestion, of course. And we will see how the single reaction chamber can improve this part, especially for such difficult samples to digest. Yeah, these are difficult samples to digest because normally these samples are very stable. As I said, these are special materials that are designed to work under very extreme conditions. In some cases, are even designed to be resistant to acid corrosion. So these, of course, put more challenges in the sample preparation, where we have to digest the sample using the acids. So most of these type of materials are made with stable chemical bonds that requires high energy to be broken. So that means that we need to work with instruments able to reach very high temperature and pressure conditions. Together with this, another challenge that comes for the sample preparation of these samples is related to the compositions and the acids that we have to select in order to fully digest a specific material. Because, as I said, advanced materials includes catalyst, includes graphene, includes a wide variety of matrices. And for each sample, there is a specific compositions, and of course, we have to choose the right acid according to the composition of the sample. And these increase the time of the method development. And the last things that we have to consider when we talk about the sample prep of these materials is the time. Normally, the digestion time of these samples is very, very long. Digestion methods can take several hours. In some cases, if you work with hot plate system, even days. Thanks to the microwaves, we were able to shorten this time, the sample preparation time. However, there is another things that we have to consider that is related to the method development. As I said, each sample needs its own chemical, its own acid mixture to be fully digested. And of course, it requires time to find the right acid chemistry to use and the right temperature to use in order to fully digest the samples. And of course, the method development is something that we have to consider, because moving from one sample to the other, it means that I have to find a new acid mixture and find a new microwave program to completely digest my sample. And this requires time, in some cases even several days. So let's analyze a little bit what does it mean advanced material. I mean, the advanced materials, as I said, include a wide range of different matrices. But normally we can divide these matrices in two big groups. We have organic samples and inorganic samples. Organic materials are all carbon-based materials that normally are easy to digest. You just mix them with nitric acid, some peroxide, and then the digestion temperature takes place between 180 to 120 degrees. And normally the digestion takes no more than 30 minutes, 1 hour maximum. But if we focus on the other group that are the inorganic samples, and most, let's say 90% of the advanced materials are inorganic, most of that samples requires, as I said, a specific acid mixture according to the composition according to the material that we have to digest, and the temperature range is much wider. We are talking about a range from 200 degrees up to 280 degrees. And as I said you before, the sample prep normally requires different hours. Nowadays, it is well recognized, and I'm sure that most of you already have a microwave system. And as I said, it's well recognized. The best unit for sample preparation is a microwave system. So if you have to perform elemental analysis for ICP, it's difficult that you don't consider at least a microwave system. There are different types of technologies of microwave system. The major used microwave units are the rotor-based unit and the single reaction chamber. Today, we focus our attention on these type of technologies because these technologies really brings very important aspects and very important benefits for the digestion of such type of materials. But before to give you all these benefits, let's analyze the factors that we have to consider when we are digesting the samples. So the first thing to consider is the sample amount, then the acid mixture, and then the microwave program. So the temperature and the time. Sample amount, so starting from the sample amount, of course, we have to take an amount of sample that is representative, considering first the homogeneity of the sample, and second, the type of analyzer. So if you are running digestion of sample, if you are running the analysis of the sample with an ICP-OES, it's different if you work with an ICP-MS, because the detection level is different from one unit to the other. And these have an impact on the sample amount. However, consider that normally for this type of materials, for advanced materials, we recommend a sample amount between 0.1 and 0.3 grams. The sample amount usually that we select is not big, also because we using 100 milligrams of samples, we want to improve the contact surface between the sample and the reagent. So in that way, we have more chance to fully digest these samples while we run the digestion program. As I said, the acid mixture plays an important role in the digestion of advanced materials. So if you are digesting an organic samples, as I said, it's easy. Nitric acid, in some cases, nitric and peroxide are used. But if you are digesting, for example, a catalyst material, a silicon-based catalyst, probably you need some hydrofluoric acid. If it is an alumina-based catalyst, you need to work with phosphoric and sulfuric. Or if you have a very particular samples with a very stable chemical bonds, in some cases it's required the use of perchloric acid. The use of perchloric acid is very rare, and it is used only for some specific samples. And at the end of this presentation, I have one sample to show you that use a very special chemicals for the digestion. However, we will see this later. But as I said, the acid mixture plays an important role for the complete digestion, to obtain the complete digestion of the sample. What we can say about the reagents is that the single reaction chamber technologies allow you to reduce the volume of reagents for the digestion. So you can really minimize the amount of acids, and these basically allow you to have some advantages. So you just need the amount of acids that the stoichiometric amount of acid that it's required to fully digest your samples, because this unit doesn't control the temperature directly from the vials, but it controls and create an equilibrium of temperature in all the positions. So then they control the temperature of all the reactors. And the advantage is that you can obtain from this unit is basically it's a reduced cost of the high purity. So it's a cost saving of high purity acids, of course, because you work with really small amount of acids, just 5 ml, 4 ml usually, and then reduce also the limit of detection of your analysis, because you can minimize the amount of reagents, then allow you to reduce possible contaminants that are inside the reagent that you are using, and then the blends are much lower, much better. And of course, this reduce also the impact on the analysis of your ICP system. So the maintenance cost of your ICP system, since the final solutions is has a low concentrations of acid. Concerning the digestion conditions, what we have to normally consider for a microwave program is the temperature. So the parameter that normally we check and we consider for the digestion of the sample, it's only the temperature. The pressure is important for the safety of the operator, and modern microwave systems are all designed to handle high pressure conditions, especially the single reaction chamber, that allow you to work at very high pressure conditions. And this means that allow you to work at much higher temperature conditions. So with a rotor-based unit like this one, the maximum temperature you can reach is 240 degrees. With a single reaction chamber, you can work up to 280 degrees. And higher is the temperature, then faster are the digestion, and then more chance you have to fully digest your sample. So you can digest even samples that are not possible to fully digest in a rotor-based unit. And consider that higher is the temperature, then better is the digestion, is the final solutions that you obtain for the analysis. The other advantage that you have working with this type of technology is, of course, the possibility to mix different type of samples. As I said, advanced materials are made by include a wide range of matrices, and you can digest all of them together in one run, because the system is designed to create equilibrium of temperature and pressure across all the vials. And this is a big advantage also if we consider the method development, where you can put in different vials the same samples with different acid chemistry, with different acid mixture, and then you can check which mixture is the best one for the test. And this is something that is not possible with a rotor-based technology. But with a single reaction chamber, you have this advantage, and these reduce a lot the method development time that normally is required for to find new acid chemicals, acid mixture for digestion of that sample. So use of the single reaction chamber for these materials improve the basically thanks to the high performances of temperature and pressure of the unit. You have you basically digest very different type of material. It's possible to digest materials with a very stable chemical bonds and inner materials. Then you can reduce the total volume of acids that normally is required for digestion, and then you can reduce the digestion time. And of course, all these aspects, there is, as we have seen, there is the possibility to mix different type of samples, different type of reagents, acid volume in all the vials, across all the vials, to speed up the method development time. And concerning the method development, Milestone gives a big support about from an application point of view. So you can find already methods, digestion method from our inside the library of the system. So there are library on the software of the unit that where you can find different methods ready to be used for the digestion of your samples. Otherwise, you can use the Milestone Connect. That is a website where you can connect directly, and you can find application notes, reports, ebooks, scientific papers, and many other materials related to the applications. So you can find really all tools that can be useful for you to develop new methods and to speed up that process. And if this is not enough, you can in any moment contact us for suggestion, test, or anything you need to find a good method to digest your samples. And concerning the materials that you can find on it, as I said, you can find different ebooks. One of them is related to the lithium-ion batteries, as like the pictures that you see here. And we did it, I bring this as an example of advanced materials, since it's a very interesting industry, because it works with a big variety of matrices. As you can imagine, these industries, there is a big expansion of this industry, and there is a big, a lot of research around in order to find high performance batteries for especially for electric vehicles. And this is an interesting application because the batteries are made by different components, cathodes, anodes, electrolyte, polymers, etc., that are used to build up, to produce a battery. And all these components advanced materials can be used for the production of all these components. And of course, the use of these special materials for production of batteries have an impact on the performance of the battery itself. And if we consider this, I want to share with you an example of one of advanced materials that can be digested with a single reaction chamber. That is the graphene nanotubes. As you can, the graphene nanotubes is used for production of batteries, of lithium-ion batteries, due to their high performance and to the unique set of electrochemical and mechanical properties. As you can imagine, the structure of this material is very particular, and it's designed to resist, it's very stable and very difficult to fully digest, because it can resist to the attack of very different kind of acids. For that reason, we have to create a highly oxidizing environment in order to break the chemical bonds between the carbons. And we need also a high energy to do that. So if we see the methods that we use for the digestion of that materials, of that samples, we use an acid mixture of sulfuric acid and perchloric acid. As I said, perchloric acid is very rarely used, but this is a good example of a sample that really needs the use of these chemicals. because without the use of these chemicals, it's not really possible to have the complete digestion of it. Normally, for most of cases, we use nitric acid, peroxide, but in that case, we really need a strong oxidation energy, let's say, to break the chemical bonds. And together with this, we digest the sample at very high temperature conditions using the ultra-wave system, the single reaction chamber system, and I'm talking about 270 degrees. And this energy, together with the chemical mixer, helps to break the carbon bonds and then to have the dissolution of these samples into the liquid, into the acid. Another point that I want to focus here is related to the volume of the acids. Notice that the amount of acids used is very small. We are talking about 3 ml of sulfuric and 2 ml of perchloric. And this is possible only because the unit, the single reaction chamber, allow us to work with small amount of acids thanks to the performance. So with the increase of the temperature, so the high temperature provides energy to the reaction that compensates the reduction of volume of these two reagents. And another aspect that is also interesting to see in this application is that working at 270 degrees, you can digest this sample in just 30 minutes. Normally, the digestion of these samples takes many hours. But thanks to the performance of that unit, of these technologies, you can really speed up the digestion process. And this is just one example out of many other examples of advanced materials. We have methods for catalysts, we have methods for other lithium-ion batteries compounds. And as I said, we recently released an ebook about just for the lithium-ion batteries. So if you are interested in this, you can download it. It's free. You can download it from our website. And if we summarize all the benefits you can get from a single reaction chamber for this type of materials, for the advanced materials, we can say that, of course, the highest working conditions allow you to get the complete digestion even of the most stable materials, of inert materials. Then you can reduce the digestion time, and also thanks to the possibility to mix several samples in the same run, and also thanks to our big support that we give together to the unit, you can make a very fast, you can shorten the time for the method development. Then it's possible to reduce the amount of the acid, and these have an impact on the cost of the analysis, on the LOD of your instrument, and on the maintenance of your ICP. So the reduction of the volume of the acid have an impact also on the analytical part, not only on the digestion part for the preparation of your sample. And then, of course, the workflow is something that have an impact, because the productivity is influenced since the work with the single reaction chamber allow you to work with different samples in one run. So you run them all together, and this, of course, speed up the digestion and the sample preparation process. So I finished the presentation, so that's all for today. Before to close and to end with this part of the workshop, I have some frequent asked questions that I want to share with all of you. Of course, you can write us your questions, and we will answer them at the end of the workshop. But however, I want to put some questions here just in order to already answer to most of you that probably want to ask these questions. The first one is related to the acid volume. So we very often receive these questions that, basically it's asked to us if it is possible to make faster digestions, increasing the volume of the acid. The answer depends about the type of sample that you are digesting. In some cases, yes. So for organic samples, yes, if you increase the amount of the volume of the acid, Of course, you can speed up the digestion process, but I mean, it's not very fast. It's not like increasing the temperature. What really speed up the reactions of digestion, it's the temperature. So if you increase the temperature, you give energy to the reactions to that, and this makes reduce the time of the digestion. In some cases, also the volume of acids can help, but it really depends about the sample and really depends about even the acid that you use. The other questions that we very often receive is if it is possible to process organic and inorganic materials all together in the same run. The answer is yes, 100%. You can mix polymers together with advanced material, together with food, even if you want, in the same run. So basically, you can create one method that digests all samples of your laboratory, and there is really no limitations in that sense. The last questions are related to the database methods and database. So how can I access the milestone methods database? So to all the applications informations. As I said, it is possible to find all these informations first from our website. So we provide ebook free that you can download, or from the Milestone Connect, or anyway, if you have a milestone system, also directly from the user interface from the software, you can find methods that can be used. And then consider that Milestone provides a service to develop the method. So if you have very special materials, and we are talking about advanced materials, so it's possible that there are new materials that comes out and that needs to be, that requires a method development. Of course, you can contact us, and then we are available to test these samples for you and to find the proper methods for the digestion. So thanks for your attention, and please continue. If you have any questions, you can write these, and then we will answer them at the end of the workshop. Thank you, and see you for the next milestone presentation.